bright beauty. Every student matters.
Now let us see some questions. It says find the number of lines of symmetry for each of the following shapes. So the first one that we see, it's a square. So we can draw 1, 2 and 3 and 4 lines of symmetry for a square. Now let's draw for this one. 1, 2, 3. Again, 4 lines of symmetry are possible for this figure. Now let's draw for C. 1, 2. Yes, I can draw it like this. 3 and 4. Again, clearly what we see that for all of these images, 4 lines of symmetry is possible in each of the case. Now let's look at here. In this particular figure, I see only one line of symmetry. I cannot draw any other line of symmetry for this figure. Coming to the E part, I can draw a line of symmetry here, 1. Then I can draw a line of symmetry here, 2. Then 3, 4, 5, 6. So total 6 lines of symmetry are possible for this one. Here, this is 1. Now talking to this F part, it is 1, 2, 3, 4, 5 and 6 again. So here we can see that in these 3 images, 4 lines are possible as the line of symmetries in all these images. In the D part, we have got just 1 line of symmetry, and E and F part, we have got 6 each. Moving to this one, G part, we cannot draw any line of symmetry here. Okay, if we are going to draw a line of symmetry, see here, then the figure will be something like this if we complete it. But this is not correct. So this is not dividing it into exactly 2 halves. I cannot draw a line of symmetry here. Why? Because this is also not giving me the exact figure. This is not how I can complete this image. So this particular figure G has got 0 line of symmetry. Okay. Now let's look at this one, H part. Clearly, I see that I cannot draw any line of symmetry for this H part as well. So again, this has got 0 line of symmetry. Moving to the next one, it says, copy the triangle in each of the following figures or square papers. In each case, draw the line or lines of symmetry, if any, and identify the triangle, the type of triangle. Some of you may like to trace the figure by using and try the paper folding first. So what you can do, there are many ways to try this question. Either you can use the trace paper and trace this particular triangle on the trace paper and then try to fold. The exact images that you see overlapping will give you the number of lines of symmetry for this particular image, right? So here, if we can see in the first image, let's count. If you see 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. This particular first figure is equilateral triangle that we see in front of us. So we have learned this already, that equilateral triangle can be divided into exactly 3, like we can divide this particular triangle into 2 equal halves by 3 different lines of symmetry. So this is 1, 2 and 3. So because this is equilateral triangle, so we have got total 3 lines of symmetry. Okay. Now the next one, this is an isosceles triangle. Isosceles triangle. And in isosceles triangle, we have got just 1 line of symmetry. Okay. Now here, this one that you see is again a right angle, and it is isosceles triangle as well. Okay. So what we can do, we can draw 1 line of symmetry over here, right? So here again we have got 1 line of symmetry, and in the last one we can see this is a scalene triangle. Let's write it here, scalene triangle. So scalene triangle has got 0 line of symmetry. We cannot draw any line which can divide this triangle into 2 halves. So here let's just write, if this is right angled isosceles triangle, it will have how many? It will have one line of symmetry if it is isosceles. If it is scalene triangle, it will have 0. If it is isosceles triangle, it will have one line of symmetry. If it is equilateral triangle, it will have 3 lines of symmetry. Okay, so make sure that you do remember equilateral, 3 lines of symmetry, isosceles, 1 line of symmetry, scalene triangle, 0 line of symmetry. Okay. Moving to the next one, it says complete the following table. Here we are given a shape that is equilateral triangle. The first one has been done for us. The rough image of equilateral triangle is shown to us, and then it is given the number of lines of symmetry that are possible. So as we already know that for equilateral triangle we can draw 3 lines of symmetry. Let us try for the other images as well over here. Starting with the equilateral triangle, we will draw this ourselves. Okay, so I am putting the image of an equilateral triangle here. Okay, so this is an equilateral triangle that we have drawn, and now let us draw the lines of symmetry to it. So 1, 2 and 3. So from each of the vertex we can draw 1 line of symmetry. So total 3 lines of symmetry are possible for equilateral triangle. Now moving on to the next image, that is a square, right? So we know that a square has got 4 sides, and all the 4 sides, they are equal to each other. So how many do we know? I hope you do remember that we learned this already, that a square can have 1, 2, 3 and 4 lines of symmetry. That is 1 vertical, 1 horizontal and 2 that are the diagonal lines of symmetry. So total 4 lines of symmetry are possible for a square. Now let us talk about a rectangle. And I'm sure you do remember from your previous slides how we learned about a rectangle. And we can draw total 1 and 2 lines of symmetry for a rectangle. Moving to the next one, it is isosceles triangle. What is the property of an isosceles triangle? Isosceles triangles are those which have got 2 lines, 2 sides equal, right? So this is an isosceles triangle, say. So if I'm dividing this, it will be exactly 1 line of symmetry that is possible. Okay, so this is 1 line of symmetry for isosceles triangle. Moving to rhombus. I hope you do remember what a rhombus is. A rhombus is a shape which is kind of a squashed square, right? Even though it has got all the sides equal, but we cannot draw any of the line of symmetry diagonally. You can try this yourself. If you take a cutout of a rhombus, you will see that you cannot draw diagonals as the line of symmetry of it. That is, you cannot draw this kind of a line of symmetry for the rhombus. These two are not possible, that we draw along the sides. We cannot draw this for a rhombus. Only line of symmetries that are possible for rhombus is the lines that we draw along its diagonals. Okay, so I just said it the other way earlier. It is that if you're talking about rhombus, you cannot draw the vertical and the horizontal line of symmetry. What you can draw is the line of symmetries that are along its diagonals. Okay, so if you want, you can try by drawing a rhombus yourself, and in total it has got 2 lines of symmetry. Now coming to a very interesting shape that we know as a circle. Now why is this shape interesting is that here in a circle, what do you think? If you draw a circle on a paper, how many different ways do you have in order to divide this into 2 halves? This is one of the way I can do it. This is another way. This is another way. This is another way. Then this is another way. I can draw this. I can draw this. I can draw this. And as a matter of fact, I can draw infinite number of lines in a circle, which will be the lines of symmetry. So infinite is the answer for circle, that how many lines do you have as the line of symmetry? Infinite number of lines are possible as the line of symmetry in a circle. Okay, now moving ahead, it says, can you draw a triangle which has exactly one line of symmetry? I hope you do remember that what kind of triangle has got only one line of symmetry? An isosceles triangle, right? So if I can draw a line right here in between, this is isosceles triangle. An isosceles triangle has got only one line of symmetry. Then it says exactly two lines of symmetry. Do you think it is possible to draw a triangle with exactly two lines of symmetry? It is not possible. So, no, we cannot draw a triangle with exactly two lines of symmetry, right? Because the reason is, if you want to try yourself, if you draw a scalene triangle, only three types of triangles are possible, right? It can be either scalene, it can be either isosceles, or it can be equilateral. So if you're drawing scalene, then it is not possible to have any line of symmetry. If you're drawing an isosceles triangle, then only one line of symmetry is possible. If you're drawing equilateral triangle, then we have got three lines of symmetry. So there is no such case that you can have two lines of symmetry in any triangle. Okay, now it says exactly three lines of symmetry. So I'm sure that the answer is already with you. If you draw an equilateral triangle, then it will be having exactly three lines of symmetry. So it's 1, 2 and 3. Oh, this 3 is really bad. And 3. Okay, so this is the kind of image that I can do my best. So exactly three lines of symmetry is possible with equilateral triangle. Okay, now it says no line of symmetry, so it is possible with what kind of triangle? Scalene triangle. Okay, a scalene triangle has got no line of symmetry. I hope you know what scalene triangle is, where all the sides that you have, they are all of unequal measure. So if I'm drawing here, say this is a scalene triangle, all the sides are of different length, right? The next one is, on a squared paper, sketch the following. We need to sketch a triangle with a horizontal line of symmetry but no vertical line of symmetry. Okay, what do we need? We need to draw a triangle. Here I am not using any square paper. I am just drawing a rough image. So you can try to trace this kind of image in your graph paper. It is a square paper, right? So it is saying a triangle with horizontal line. So horizontal line, I am just drawing the line of symmetry at first. So if this is the line of symmetry that is horizontal, I need to draw a triangle on it, and it should not have any vertical line of symmetry. So if I am drawing an isosceles triangle, that is these two sides, they are equal to each other, then I'll have only horizontal line of symmetry for this particular triangle. Okay, now the next one is a quadrilateral with both horizontal and vertical line of symmetry. It's simple. What shape is a quadrilateral? It is the shape that has got four sides, right? So if I'm drawing a rectangle, clearly it will have how many lines of symmetry? It will have a horizontal line of symmetry and a vertical line of symmetry. This one is horizontal, and this one here, the standing line that we have, is vertical line of symmetry. Okay, now let's move ahead. We need to draw a hexagon with exactly two lines of symmetry. So we need to draw a hexagon, that means it needs to have 6 sides, right? So these are the 2 sides, 3, 4, 5 and 6. Okay, and if it's having 2 lines of symmetry, so this will be 1 and this will be 2. Okay, I have elongated these 2 lines here so that I cannot have a regular fixed shape, so that no further lines of symmetry are possible. Okay, moving to the next one, a hexagon with 6 lines of symmetry. So I'll just insert the image of a hexagon here so that it's good to have a clean image. So this is a hexagon, right? And let us draw the lines of symmetry, and total 6 lines of symmetry are possible if you are looking into a hexagon, right? So this is, I'll just put the good lines, straight lines, okay? So this is 1, okay? Then again, this is 2, then we have got a 3, right? So these are the 3 lines that we have drawn. I think I should redraw this line here. It's not looking much neat though. I'll just try it again. So let me just insert the lines again. So this is 1. I'll just try from the sides at first. So it's here 1, 2, then 3, that is joining it horizontally. Then I need another one here. It's 4. Then I need another one here. It's 5. Right? And another one, 6. Okay, so these are the 6 lines of symmetry that we have drawn for this given figure, hexagon. And as we know that hexagon has got 6 sides. So how many total lines of symmetry we can see? 6 lines of symmetry, and make sure it is regular shape. So this is here a regular hexagon. Only this is the reason why it is having 6 lines of symmetry. Okay, if you don't have a regular hexagon, you can never have 6 lines of symmetry. Moving to the next question, it says trace each figure and draw the line of symmetry, if any, is possible for these given figures. So look at the first one, that is the A part. Do you think it's possible to have a line of symmetry for A? In the A part, if they have given us a line, this particular triangle as an isosceles triangle, then this kind of, I'll just redraw it, then this kind of a line can be its line of symmetry if this is an isosceles triangle. If it is a scalene triangle, then no such shape is possible. But as we have got this extra line here, right, so we cannot draw this as the line of symmetry, so it's not possible to draw in. Okay, now let's look at the next one. Here clearly we can draw this as the straight line, which can act as the line of symmetry. Again, what we can do, we can draw it like, we can draw a horizontal line over here, and this will also divide it into 2 equal halves, right? So 2 lines of symmetry we have drawn. Now let's look at the C part here. Clearly we can draw 1 here, 2 here, 3 in the diagonal, 4 in the diagonal. So total 4 lines of symmetry we have drawn for this one. Then here we have got 1, then 2. So 2 lines of symmetry. Then here we have got 1 line of symmetry. We have got 1, 2, 3 and 4 lines of symmetry that are possibly drawn on this particular image. So again, 4 lines of symmetry. Now let's move ahead and see. It says consider the letters of English alphabet A to Z. List among them the letters which have a vertical line of symmetry like A. Look at this alphabet A. If I can draw a straight line in between, clearly this is the line of symmetry, that is a vertical line of symmetry for A, right? So let us see which other alphabet has got as similar to A, a vertical line of symmetry. Clearly B has not got it. We cannot have the same for C, neither for D, for E, F, G, H. H has got a line of symmetry, but here, yes, I can draw 1, but I can have 2 lines of symmetry for A. So here I'm just writing H because 1 line of symmetry is definitely possible, that is vertical line of symmetry, right? Now for the letter I can draw, I can just put a half line exactly in between. So I can be 1, J, K, L, M is one of the structure that can have a vertical line of symmetry. Then O is definitely a 1. Then we have got T as the line alphabet. Then U can have the same. V can have the same. W can have a vertical line of symmetry. X can have a vertical line of symmetry. Y can also have a vertical line of symmetry. Now horizontal line of symmetry like B. So B can be divided like this, right? So it has got a horizontal line of symmetry. So C can also have a horizontal line of symmetry. D can have a horizontal line of symmetry. E can have a horizontal line of symmetry. F, G, H, K. K has got a horizontal line of symmetry. Then L, M, O can have a horizontal line of symmetry. Then do we have any other? Yes, we have got a X. X can have a horizontal line of symmetry, right? No line of symmetry like Q. So clearly F is one of them. It cannot be divided either vertically or horizontally. G is another one. J is the other one. Then we have L. Then we have N. Then we have P. Then we have Q itself. Then we have R. Then we have S. And then we have Z. So all these are according to the vertical line of symmetries like A, according to B, which is having horizontal line of symmetry, and like Q, that is having no line of symmetry. Moving to the next one, it says given here are figures, a few folded sheets and designs drawn about the fold. In each case, draw a rough diagram of the complete figure that would be seen when the design is cut off. So if this is the line of symmetry and this is how a paper is folded and this kind of a structure is cut out of it. Right, so if we just open, I'm just drawing a rough part here. So if we open, we'll see something like this. So here it's a bigger cut and here it's a smaller cut. So something like this will be visible, right? So I'll just redraw it. Yeah. So a bigger cut and then a smaller cut is seen, right? So this is the kind of a structure that can be seen. Something is really wrong with my drawing. I'll just redraw it once again. Okay, this will be the last attempt. So one, a deeper cut, and then we have got a smaller cut, right? So this is the kind of a structure that we will see. Moving to the next one, here we have got something like this. Here, this is something that we can see, and if we open it, it will be the same thing that we will see on the other part as well. Okay, so again, this is something that I've drawn really bad, but if you try, make sure you use this ruler, sharp pencil and everything to draw such structures, right? And with this, we have completed this particular lesson where we learned about the lines. We are having the figures which are having two lines of symmetry and the figures that have got multiple lines of symmetry. And with this, we are done with this particular lesson of multiple lines of symmetry. In the next lesson, we learn something more in symmetry.